If you manage an engineering team and you still run the same interview loop that you did 3 years ago, you're hiring from a broken filter. AI changed the game. Can they name the pattern? It's worthless now. A chatbot can do that in 1 second. But here's what a chatbot still cannot fake. Experience. And here are 3 patterns that expose it faster than any other questions in your toolkit. You watch it happen. A hire accesses the interview, joins the team, and 3 sprints in every PR review develops into why is this function 400 lines? Meanwhile, the quiet one you almost passed on is quietly shipping the cleanest code on your team. Your filter is catching the wrong signals. The usual fix is to add more steps, more interview rounds, harder take-homes, another pair programming session. You are adding friction, not signal. What you're missing isn't more, it's sharper. The highest signal question you can ask a candidate isn't define observer, it's show me what you reach for when nobody tells you the pattern name. The highest signal question you can ask a candidate isn't define the observer or how would you make this feature. It's show me what you reach for when nobody tells you the pattern's name. 3 patterns: observer, singleton, factory. Reveal that instinct in 10 minutes, no whiteboard required. In this video, I'm handling you the exact hiring test, green flag and red flag for each one. By the end, you will have a 10-minute conversation that outperforms a 90-minute interview loop. Let's go. Let's start with the core design pattern used in React, and it's observer. This one is the behavioral type of the design pattern. You have a few things available here. So we have the subject and the observers. If the subject changes, then observers react to that change. Core idea is publish once and react in many places. The easiest way to explain this is how the use state is working in the React, because this is the pure observer implementation. You have the state that is a subject, you have a component that is the observer, and the re-rendering event is the notification. In the native DOM elements, you have the few built-in methods, which are add event listener, event emitter. Also, the WebSockets work in the same way. When the server sends the event and you react on this on the front end. The React subscription is very similar. Also, the Redux subscription is the good example of the observer pattern. It works very similar to use state. Best implementation in TypeScript is the event bus, when you have the on and the emit, which communicate with each other. So you can emit event once, and in the on method you just catch this emitted event. That one, event bus, is actually it's the good example from the classic web development point of view. Not really used that often in React, and actually in React it's the anti-pattern. Let's move to the example, and of course the easiest one is the single line of code used in React, which is the use state, set count and count, where React by itself is the subject. Your component when you use this hook is the observer, and the set count triggering this method is the re-render notification. If you want some more advanced example, you have this event bus class. When you create the new instance of the event bus, you have the object that is subscribing on the change. So when this user logged in, it's passing the user to console log here, user with the user's name, and to emit event you just use the same key as the object that is catching this event, and you just pass the new state of it. And you have here example implementation. When you have class, you have the private method where you have records, you have available method on and emit, where on takes as the parameters event and callback. If the listener doesn't exist, then if the list of the listeners is empty, it creates the new list, and then it pushes the new event with the key that you passed to this list, and also add the callback method that is pushed on the listeners list. The emit method takes event and data, where event is the same key as the on method, and the data is the new change state. And here, as you can see, you have this listeners event, and every one of them have this function attached, where callback returns callback called with the data. Next is the singleton pattern. The singleton pattern is basically the easiest of the design patterns, and that one is the creational design pattern. So this is the way how you create the object. You have only one instance for all of your application ever, and it's shared globally across the entire app. The most common use case is the database connection pool, app configurations, some logger, or authentication token manager. The pattern itself looks like this. You have class, you have the private instance that is static, private constructor, and you just get the instance by calling the method. So you make only the one instance of this object per your application, and you just get the instance everywhere where you need it. Yeah, and the most controversial part is people confuse it with global mutable state, which is something that you have to avoid because it would trigger re-rendering of all of the applications, and it would have many side effects. Basically, it's very difficult to handle the parts of the application that will be re-rendering. So in this case, when you have read-only config or single resource, it's a good use case. If you have mutable shared states, then probably it's not a good idea. Now let's jump to the implementation. In this example, you have the classic database connection. Right here, as you can see, the usage is the database object. When you use the instance of the class by itself, you don't make the new instance of the class using the new constructor. This is the important part. You just use the class and use the method getInstance. The class by itself have the private instance, as you can see here, and the private constructor. And the constructor and instance are managed only from the getInstant method. So if you're calling the getInstance for the first time, it creates the new object internally using your database URL, and then every time when you call it again to get the instance of this class, it will just return the static private method that you already have here. When you have instance, you can also run the query method on it. Let's move to the next design pattern, which is the factory. So the factory is also creational design pattern. It's used to create new objects. It's something completely different than singleton before. It can be function on the class, and the color don't have to know what is the internal implementation of it. So we just make the new instance, and you just pass the type of the output object that you need, and the factory is basically the encapsulated implementation of the logic. So the real life use cases are the payment processor like Stripe and PayPal, notification senders, and test mocks. So looking at the payment processors, you can have one factory class that takes the Stripe or PayPal as a string argument to create the instance of the payment that you want to implement. The best part of this pattern is that it's very easy to test because you can pass the mock anything that you need, and you should have always the same output. And you can take the fake processors for every use case of this factory class. Let's jump to implementation. So in this case, our usage is the processor object. We don't have to know how it's implemented. We just create the payment processor, we pass the string, we want to have a Stripe, and we just want to use this processor to charge the user some amount of money. To have a better control of it, you have the provider's type, which in our case is Stripe or PayPal. So you can pass one or another type of it, and you can catch this inside your create payment processor method. So when you call this method, you pass the provider, which is one of the two available, and it returns the object, which is the payment processor. So if the provider is Stripe, then we create new Stripe processor. Then we create the new instance of the object, Stripe processor. This is one of the use cases of the factory design pattern. And we take this Stripe processor, that is also the interface of the same class. So every payment processor that we'll implement must use the same interface, which is the payment processor, because we will know how to use it as the developer, as the end result. As you can see, both types of the processor use the same interface, and they both implement their own logic for the existing interface. In this case, we have the async charge method that was declared in the interface, where we pass the amount, which is the number, and it returns the promise. So as you can see, it aligned with our payment processor interface. And using the factory pattern, you can implement as many payment processor as you want. You can always extend this object, which really good align with the open close rule from the solid principle. So there it is, observer, singleton, factory. 3 patterns, 3 10-minute conversations, 3 hiring signals that most interview loops completely miss. The thing I want you to hold on is this. You are not testing vocabulary. Vocabulary is free. Any candidate can name these patterns by the end of the 5-minute Google search. You're testing instinct. The candidate who reaches for a decoupling without being told to, who distinguishes shared infrastructure from pay user state on reflex, who finds the existing SIM instead of piling of if branches, that is the hire. And they almost never interview the loudest. Here's your homework. Next interview run, pick one of these 3. Run it in the code scenario, not definition question. Watch what the candidate reaches for in the first 60 seconds. You will know more in that 10 minutes than most interview loops get in an hour on either days. If hiring frameworks like this are what you want more of, plus review protocols and engineering team structure in the AI era, my community is room for you. Link in the description. If you need a private consultation, project review or audit on how the team is structuring patterns like this, link in the description. Book a call. We'll spend 30 minutes on our actual code base. See you in the next one.